Hi. So what we have here is a system of three equations. Now the problem is asking us to find the position equation with the given data. So an object moving vertically is at the given heights at the specific time. So find the position equation. S is equal to 1/2 at squared plus v naught t plus s naught for the object. Now the information that they give us at 1 second, at t is equal to 1 second, our position is 156 feet. At t is equal to 2 seconds, our position is 108 feet. At t is equal to 3 seconds, our position is 28 feet. Now here I do have the answer to this problem, but we're doing this so we can check to verify that that we get the same answer. So what we have to do here, at the specific times, at 1 second, 2 seconds, 3 seconds, we have to plug this information into the position equation that we were given in the original problem. So at t is equal to 1 second, where s is 156 feet, what we got to do is we take 156 equals 1/2 a times 1 squared plus v naught times 1 plus s naught. Now whenever all we're doing right here, we're plugging in t in for t and s in for s. Okay, so our final equation, whenever we solve this, whenever we simplify this, should be 156 equals 1/2 a plus v naught plus s naught. Now what we're going to do here, we're going to do a little bit of trickery. Now the reason why we're going to do this is because we really don't like to have fractions. So we're going to take each part of this equation that we just wrote down and we're going to multiply it by 2. And the reason why is because it gets rid of this 1/2 as a fraction. So when we multiply each little piece by 2, well then we get 312 equals a plus 2 times v naught plus 2 times s naught. Now that's going to be one equation that we're going to deal with. So I'm going to specially mark that with a little red star. Now we're going to do the same process with the second set of information. T is equal to 2 seconds, where S is 108 feet. So 108 equals 1/2 times A times 2. Times 2 squared. Plus v naught times 2 plus s naught. So that means we'd have 108 equals 1/2 times 4a plus 2 times v naught plus s naught. So when we simplify this, 108 equals, well, 1/2 times 4, well, that gets us a 2a. And then we have 2v naught plus s naught. Now thankfully we don't have a fraction, so this is as far as we can go on that particular equation. So I'm going to star that one because we are going to come back to it. Now on the third set of information, your t is 3 seconds and your s is 28 feet. So this would be 28 equals 1/2 a times 3 squared plus v naught times 3 plus s naught. So we got 1/2 times 9a plus 3 v naught plus s naught. Now that we have a fraction, we have that 1/2, we're going to multiply every part of that equation by 2. So we'd have 56 equals 9a plus 6v naught plus 2s naught. So I'm going to star this one because we're going to come back to it. Now, the reason why I wanted to star each little equation is because we now have our system of equations. Our first equation is going to be the first equation that we starred earlier. Okay, so it's going to be the first one. A plus 2v naught plus 2s naught equals 312. The second equation, 2a plus 2v naught plus s naught equals 108. And the third equation, 9a plus 6v naught plus 2s naught equals 56. So this is the system of three equations that we will be dealing with. Now, I will admit I do things a little differently. The reason being is because I ultimately want to deal with a system of two equations. I despise dealing with a system of three equations. So what I'm going to try to do, I'm going to do everything I possibly can to eliminate one of my variables so that one of my equations can go away and I'm left with a system of two equations. Okay? All right. So what we're going to do, I'm going to try and eliminate my a values right here. So how I do this is basically, let me write everything real quick. I'm going to take, well, let me label my equations. So my first equation is 1, my second equation is 2, and my third equation is 3. Okay? So I'm going to take my first equation, so multiply equation 1 by a negative 2, then add to equation 2. All right, that's the process I'm going to do. So if I take equation 1 and multiply every term by a negative 2, well then I get a negative 2a minus 4v naught minus 4s naught equals a negative 612. I apologize, negative 624. Okay, now I'm going to add it to equation 2. Now equation 2 was 2a plus 2v naught plus s naught equals 108. So when I add that, well, guess what? My 2a's go away, and I'm left with a negative 2v naught minus 3s naught equals a negative 516. Okay, so I am going to now star this one. Because I'm definitely going to come back to it. So, the next step I'm going to do, I'm going to multiply equation 1 by negative 9. Now you're probably wondering, where am I getting these numbers to multiply? I will be the first to admit, it does take practice and you do have to play with it a little while. You got to be able to figure out what variable you want to cancel out and do everything you can to cancel that variable out. Here I'm wanting to cancel out my a's. I'm wanting to make sure that they ultimately go away. So that's how I'm able to decide what numbers I have to multiply by in order to subtract my a values out. So going back here, I'm going to multiply equation 1 by a negative 9 and then add to equation 3. So when I take the first equation, okay, first equation is a plus 2v naught plus 2s naught equals 312, and I multiply that by a negative 9, well, what I get is a negative 9a plus, I apologize, minus 18v naught minus 18s naught equals a negative 2,808. So I multiplied equation 1 by negative 9. Now I'm going to add that equation to equation 3. So I have a 9a for equation 3 plus 6v naught plus 2s naught equals 56. And when I add these two equations together, lo and behold, the negative 9's, the 9a's go away. So all I'm left with here is a negative 12v naught minus 12s naught, not 12, I apologize, negative 16, equals a negative 2,752. So I'm going to come back to this equation and I'm going to start real quick. All right. Guess what? These two equations that I have starred down here, those are going to be my system of two equations that I'm going to actually be able to play with. So there's the easy part. There's the fun part. So I reduced my system of three equations down to a system of two equations. So my new system is a negative 2, let me get a different color here. It's going to be a negative 2 v naught minus 3 s naught equals a negative 516. And then negative 12 v naught minus 16 s naught equals a negative 2,752. So there's our system of two equations, which we can do by substitution, elimination, or we can graph it. Well, here, what I'm going to do, on this particular problem, I would do elimination. Basically, I would take equation 1 in Roman numerals, and I would multiply equation 1 by negative 6, then add to equation 2. Well, why negative 6? Well, if I multiply the first equation by negative 6, you see that your v naughts would cancel out when you add them together. So when I go ahead and do that, I will get a positive 12 v naught plus 18 s naught equals a positive 3,096. Now I'm going to add it to equation 2. So just for verification, equation 2 was a negative 12 v naught minus 16 s naught equals negative 2,752. So when I add those two equations together, I get, lo and behold, my 12 v naughts go away, and I'm left with 2 s naught equals 344. So now my v naughts go away, and I'm only left with an s naught. Here, all I have to do is divide both sides by 2, so I get an s naught value of 176. Goodness, I cannot do math today. I apologize. 172. There is one crucial part right there. That's the beauty. That's the beautiful part. So now we're getting somewhere. So here we can take this s naught and we can back substitute. So we can back substitute our 172, and for any of the two equations, I or Roman numeral 1 or Roman numeral 2. So what I did, I back substituted it into Roman numeral 1. So what we have is now negative 2 v naught minus 3 times 172 equals negative 516. When you multiply that, you solve it out, you get a v naught which is equal to 0. That's also very important. Okay, so we have the values for s naught, we have the values for v naught. Now we can actually go back to one of our original equations and figure out what our a value is. Okay, so I'm going to go back to the original equation, the original system, and I am going to, let's see here. Which one do I want to play with? I'm going to plug it into the first one. So the first one was A plus 2 V naught, but V naught in this case was 0, plus 2 S naught, which is 172, equals 312. So here, 2 times 0 is just going to be 0. So I have A plus 344 equals 312. Solving for A, then we would get an A value of a negative 32. We found all the missing parts of our equation. So now we can actually figure out the answer. So our final answer, when we plug it in, would be S is equal. We're plugging it back into the position equation that was given to us originally in the problem. 1/2 times your A value, which is negative 32, T squared. But the reason why we're using T squared and not one of the specific T's is because we're trying to find the general position function. So T is just going to be T in this case. Plus V naught T, which in this case, V naught was equal to 0. So that would be 0T. Plus S naught, which in our problem, S naught was 172. So now when we simplify it, well, 1/2 times a negative 32, well, that should give us a negative 16 T squared plus 172. And this is our general position function for our problem using the times and the positions that they give us. Now the problem actually has it written backwards. They have it 172 minus 16t squared. Either one would work. Okay, either version would work. So really the hard part about doing a system of 3 equations is reducing it from a system of 3 equations down to 2 equations. And then once you get it down to 2 equations, then you can do the elimination or substitution or graphing method that we've learned before. But like I said, the hard part is keeping track of the signs whenever you're reducing it from a 3 equation system to a 2 equation system.